Iran paid over $800 million for it, deployed it across the country, crews trained for years. Iran built its entire air defense architecture around it. The S-300 PMU-2 was supposed to be the system that finally closed the gap. It was the missile that could reach American aircraft before they reached their targets. In 5 weeks of Operation Epic Fury, it failed to shoot down a single American bomber. Not one B-52, not one B-1B, not one B-2. There were over 1,000 bomber sorties and hundreds of cruise missiles. Deep penetrations into Iranian airspace followed. The system Russia sold as the most capable air defense on the market outside of the S-400 could not stop any of it. Why? The answer is not about the missile. It is about the system behind it. Understanding why the S-300 failed over Iran changes how you understand every air defense network on Earth. The S-300 PMU-2 is not a weapon. It is a network. A single battery consists of a surveillance radar, a target acquisition radar, an engagement radar, a command post, and up to 12 launch vehicles. Each component talks to the others in real time. The surveillance radar finds the target at long range. The acquisition radar tracks it. The engagement radar locks on. The command post decides when to fire. The launchers execute, remove any single node, and the battery degrades. Blind the surveillance radar, and the acquisition radar searches without warning. Destroy the command post, and the launchers cannot be cued. Jam the engagement radar, and the missile flies without guidance. The network is the weapon. Epic Fury attacked the network, not the missile. On the night of February 28th, before a single bomber crossed the Iranian border, F-35s and Tomahawk cruise missiles struck something specific. Not the S-300 launchers, the radars, the command nodes, the fiber optic cables connecting distributed radar sites to central processing stations. Cyber operations degraded the data links that allowed individual batteries to share tracking data across the country. Iran had distributed its radar network precisely to survive this. No single strike could blind the entire system. They had studied Desert Storm, Allied Force, and Iraqi Freedom. They knew how America opens an air campaign. So they built redundancy into every layer. But redundancy requires communication, and communication requires infrastructure, and infrastructure has nodes. The F-35 was built for exactly this mission. Its electronic warfare system maps radar emissions in real time. Every S-300 radar that powers up to track an incoming threat broadcasts its position, its frequency, and its operating mode. The F-35 records all of it. It feeds that data to the targeting network, and the next Tomahawk knows exactly where to go. Iran's S-300 operators faced a choice that had no correct answer. Power up the radar and get located. Stay silent and stay blind. A radar that does not transmit cannot be targeted. A radar that does not transmit also cannot track. In the opening hours of Epic Fury, Iranian crews made that choice hundreds of times. Some powered up and were struck within minutes. Some stayed silent and watched American aircraft transit their coverage zone unengaged. That is not a failure of the S-300 missile. That is a failure of the doctrine built around it. Here is the physics. The S-300 cannot escape. A radar-guided missile needs a continuous tracking solution to guide itself to the target. Interrupt the track and the missile goes ballistic. It becomes an expensive piece of falling metal. The AGM-88 HARM, carried by F-35s and EA-18G Growlers, is designed to ride the radar beam straight to the source. The moment an S-300 engagement radar activates to guide a missile, it broadcasts a targeting solution for its own destruction. Fire the missile and reveal the radar. Reveal the radar and absorb a harm. The geometry only works one way. Iran tried to compensate with shoot and scoot tactics. Power up, fire, and move before the harm arrives. The S-300 PMU-2 can execute a tactical displacement in roughly 5 minutes under ideal conditions. The problem is ideal conditions. Displacing requires unplugging power, retracting the antenna, moving the vehicle, and re-establishing communications with adjacent batteries. 5 minutes assumes a crew that is not under simultaneous attack from multiple directions. 5 minutes assumes the road network is intact. 5 minutes assumes the generator still works. Epic Fury systematically attacked every one of those assumptions. A harm travels at Mach 2. The math does not favor the launcher, but the deeper problem was not the hardware. It was the degradation sequence Epic Fury imposed. In the first 72 hours, over 1,700 surface targets were struck. Radar sites, command nodes, communication infrastructure, and power supplies to processing centers were hit. The S-300 batteries that survived the opening strikes did not suddenly become more capable. They became more isolated. Each battery that lost its data link connection to the broader network was now operating on local sensor data only. Coverage radius collapsed from hundreds of miles to line of sight. Coordination between batteries disappeared. The integrated air defense system, the network that made the S-300 dangerous, fragmented into disconnected islands. A disconnected S-300 battery can still engage a target it detects locally. It cannot be cued by a radar 300 miles away. It cannot receive early warning from a satellite downlink. It cannot coordinate a multi-battery engagement against a single target using different radar angles to defeat jamming. It is a powerful weapon operating blind, alone, and without the system that made it lethal. By week 3, the B-52 could stand 500 miles away and launch JASSMs across Iran, without a single engagement radar achieving lock. Not because the missiles were stealthy, because the radars that should have tracked them were rubble, silent, or isolated from the data they needed to function. By week 5, the B-52 was flying directly over Iranian territory, dropping 2,000-pound bombs. The S-300 batteries that survived 5 weeks of the most sustained SEAD campaign in history could not stop it. Not because the missile was outranged, because the network was gone. There is one honest caveat. The S-300 was not completely neutralized on day 1. In the opening phase, Iranian crews did achieve engagements. Several cruise missiles were intercepted. The system performed as designed in the brief windows when its radars could operate without immediate suppression. The 80% degradation figure cited by CENTCOM means 20% remained. That 20% was real and dangerous. But 20% of a network is not 20% of the capability. A network loses coherence before it loses hardware. 80% degradation of the communication and coordination layer means the remaining 20% of launchers cannot perform coordinated multi-battery engagements. They can shoot at what they locally see. They cannot execute the integrated defense the S-300 was designed to provide. Iran spent 3 decades and billions of dollars building an air defense network that would make American air power too expensive to employ. They studied every American air campaign and designed a system to defeat the doctrine behind them. Epic Fury did not defeat the S-300 by outranging it. It did not defeat it by building a stealthier aircraft. It defeated it by attacking the thing the S-300 cannot replace in the middle of a war. The network. The missile is still in the silo. The launcher is still on the truck. And it cannot stop anything because the system that tells it where to look is gone. That is the lesson no defense ministry on Earth wants to hear. The weapon you bought is only as good as the network you built around it. Networks have nodes. Nodes can be found, and found things can be destroyed. The S-300 did not fail because it was a bad missile. It failed because America attacked the right target first.